disproving conjectures with counterexamples. Now, the interesting part here is teenagers are extremely good at this. Why, you say? Because they always look for the exceptions. They always try and find, well, I don't have to because of this. Okay? This person doesn't, so I don't have to. You know? So, what we want to do is we want to look for something that's called a counterexample. Now, a counterexample is just simply an example that says, hey, that's not possible. Okay? So, if I would consider the conjecture here, if two lines are both intersected by a transversal, then they are parallel, correct? So any two lines that I've got, if they got a transversal, those two lines must be parallel. Are you sure? Would you stake your life on it? Never. Good, because you're absolutely wrong. I got a picture right here of two lines, right? And they have a transversal. That's a counterexample. That is all the more that I would need to identify that this is wrong. Bad conjecture, or I should say the conclusion is false. So, let's try this. Okay. If a triangle is isosceles, then it is acute. Now, when we do this, we want to make sure that we identify what's our hypothesis and what is our conjecture. Okay? Or I should say, what's the conclusion? So, if I want the hypothesis, which one is the hypothesis? Okay? If triangle is isosceles, the conclusion has to be what? Acute. Okay, so I've got that identified. Is this always true? What kind of a triangle could be isosceles but not be acute? A big one. What do you mean by a big one? So you want an obtuse. So you're saying I should be able to draw a triangle that is obtuse. So if I were to draw something that looks like this and say here to here, here to here, well, that's acute there, that's acute there, but this is probably obtuse, right? Yes, sir. Well, I'd have to give you some information. So if I were to decide to say that, you know what, this is going to be a 30-degree angle here. This is a 30-degree angle in here, okay? This would have to be how many degrees up here? 120 degrees. So whenever we do this, we want to make sure that we give ourselves enough information so that we can answer that question. So I've got an obtuse here, but that and that are exactly the same. Could have I also drawn out a triangle with these qualities? Got it right about there. Is that possible? Could I have a right triangle with two sides exactly the same? And if you don't believe me, all you got to do is look up. Those are all squares, right? If I were to cut a diagonal down the ceiling tile, would I have a triangle that was a right triangle with two sides that are exactly the same? Okay. All I needed to do was provide one of these things. So, every quadratic equation either has no solution or two solutions. Now, do you remember what a quadratic equation looks like? Let's see, a quadratic equation can generally be identified as ax squared plus bx plus c, okay, equals whatever. If we want, we can say it's equal to 0. Now, basically, the key component here is right in here, is this x squared, okay? That's the key to this thing, for it to be quadratic. So let's say that I had something like x squared is equal to 9. Okay? What could x be? 3 or negative 3. Okay? So I got two solutions. Is it possible to have no solutions? In other words, could I have x squared equal to negative 9? Would that be no solution? Is that even possible? Well, it is, but you don't have enough numbers to deal with it yet. We got to go to imaginaries, but that doesn't work, does it? According to what we know, we can't make that work. So, is it possible that I could have just one answer? And the answer is yes. What happens if I have x squared equal to 0? What would x be equal to then? 0. But I can't have plus or minus 0, can I? So I looked at this and I was able to come up with one of two solutions. I could come up with something that has no solutions. So the only other possibility was, well, if it has none and it has 2, could it be that it has 1? Okay. And so you got to kind of think about it sometimes. Okay. What about the one down there for B? I want to find a counter example. If 5x minus 10 is equal to 15, then 2x plus y has to be greater than 9. Well, let's see. If I were to do this, add 10, I get 5x is equal to 25, so x would be equal to 5, correct? Okay, so I am saying now that, oh, fine. I put an x up here. That means I get 2 times 5 plus y is greater than 9. Or 10 plus y is greater than 9. Okay? Did it tell us what kind of values we could use for y? Okay? Is there a value of y that would exist that would make this false? That it wouldn't work? What would be an example? What'd you say? 2 million? If I put 2 million in there, it'd be 2 million 10. 2 million 10 is bigger than 9. I don't want this to work. I want this to be negative 5. So if y was equal to negative 5, 10 plus negative 5 would be what? 5. Is 5 greater than 9? No. So we could say, I got a counterexample. If y is equal to negative 5, I could have picked any negative number, couldn't I? Okay? You're correct. Well, what happens if I had like negative 0.5? That would have worked, because negative 0.5 would have been 9.5, which is bigger than 9. So you got to be kind of careful about things when you're identifying what is what. But all I wanted to do was find a number where it did not work. Okay? That's the catch. So let's try this. I'm going to give you guys a couple minutes here, and I want you to think about this one. And I want you to do A and B. So we're going to start off with Gavin. What is the hypothesis of this conjecture? If line A is perpendicular to B and to line C, right? You sure? Wasn't the hypothesis what follows the if? Okay. So, Jacob, Don, Hayden, what's the conclusion? Okay. See your prediction. Okay, so we got the conclusion. So, should I try and draw this out? If I want to. Yeah, I know it's a free country. But, okay, so, if line A is perpendicular to line B, so is that perpendicular? I know, there's that little piece down there, don't worry about that. So, this would be A, and this would be B. So, now it says if line A is perpendicular to line B and to line C. So does that mean A has got to go through C as well? Yeah, because they got to touch in order for them to be perpendicular. So if I do that, it would have to look something like that, correct? Okay. So I've drawn that out, and now I've got that this one here is going to be C. So now, well, I'd probably want to say that that's perpendicular there because it says that, and that's perpendicular there. So, I'm supposed to find a counterexample to the conjecture. Now, did I draw out the if, the hypothesis? I drew that out. So, does this show that this is true or false? Shows that it is false. So could this be my counterexample right there? And there we go. A lot of times it'll be just easier to go and draw yourself out a picture of what the situation is and then go from there. Don't try and picture it in your head. Just draw out what it says to draw out. Okay. So, let's do this. I'll give you about 90 seconds since you guys got that one pretty quickly. There you go. Yes. So which one is the hypothesis? Okay, so the hypothesis we got is the x squared equal 9. Let's see. Then we shall go to, So what's the conclusion? You mean you mean x equals 3. Okay, conclusion. It's just what follows. Don't worry about trying to change it into anything. So, let's see. So, Anna, is this true or false? You sure? You're so the only way for x squared to be equal to 9 is for x to be equal to 3. What would be a counterexample to this? Okay. So, well, let's kind of go back with this thought then. Is there any other way to come up with this answer? What? Okay. So if I were to put down, as she says, x is equal to negative 3. So when I'm looking at this stuff, does that mean, and I mean, does that simply mean that this has got to be the only possible answer? If I am making the conjecture, if this, then that, that's all I concern myself with, okay? But because I've seen that x is equal to negative 3, there's got to be a counterexample to this, okay? Now, if it said, let's turn it around for a second. What happens if they did this? If x is equal to 3, then x squared is equal to 9. Is that always true? Yeah, it's always true. Why? Because your if is x is equal to 3. And if I have x equal to 3, x squared is always equal to 9. But if x squared is equal to 9, x is not always just 3, is it? It could also be negative 3. So you got to think about this for a minute. So I'm going to give you another 90 seconds, and I want you to think about this one. I got to have a little science once in a while, right? Respectively means that first goes with first, second goes with second. That means that 327 has to go with 275. That means that 568 goes with 501. That's what they mean by respectively. What? Well, it's okay. We's teaching you here. Okay. So, it says the masses of two sedimentary rocks are 327 and 568 grams respectively. Volumes are 275 and 501 respectively. They say, or it says, if a rock is sedimentary, and we have sedimentary rocks, then its mass is proportional to its volume. So if I got a proportion, isn't that something along these lines, like M over V? Okay. So that means that if I've got 327, that's over 275, correct? And if I had 568, it would be over 501. Now, what could I do to determine whether or not the proportions are correct? What would I do with those two numbers? Divide them? Okay, divide them. So what's 327 divided by 275? You guys got calculators, don't tell me I don't know. Leah, it's sitting right in front of you. What'd you get? 1 point, what? 1898. Okay. So do the other one now. 568 divided by 501. What do you get? $1.1237. Oh, 337? 1.2337. Okay. Ah. 1.1337. So, is this statement true? And the answer would have to be no. Because if the sedimentary rock had its mass proportional to its volume, that proportion would have to be the same for all things considered. But because it's not, we would have to say that this is a counterexample and we can disprove it just by this. Okay? All right, so you guys can get to work on your assignment.